All right, so here we are with 25. So we knew these were going to get kind of ugly at some point, and this is kind of the start of that. So this is one that's going to take a couple different pieces. And first off, I didn't do the 100 on here, so right, this should really end up being 75,000 that we get out of it. So anyways, just a note that yeah, we all have our moments. But this is one where we're going to need to really kind of think about, there's many different ways we can do it and how we want to break it down. So what we have here, let's forget the 100-acre thing, but bring it back like I didn't do there. Let's say we have a 50-year-old stand of Douglas-fir that's expected to yield $1,450 of net revenue at rotation age 60. So every 60 years, it's going to get $1,450 every 60 years thereafter, right? So we're looking at something that's perpetual. We have an interest rate of 7%. What's the present value? So here's how I might tackle that. So if I have a timeline, right, and I get my timeline out there, what I may want to do is recognize that here I am in year 0, stand age 50, right? So let's say it's year 0, age 50. And in 10 years, age 60 happens and I get $1,450. I then go out another 60 years and at age 70, stand age 60, I'm going to get another $1,450. And out here again at 130, stand age 60, I'm going to get $1,450. And that's going to go on and on and on and on. So let's ignore the main part here of this 50-year-old thing and just recognize that we have this series. And we know how to handle that series. So if we look at our sheet, right, not a single payment, it's a series. It's not happening every year. It's happening every n years. And in this case, that n is 60. It goes on forever. And when it goes on forever, I apply this perpetual periodic. And so I know that I'm going to apply that perpetual periodic, which is VO equals A 1 plus I to the n minus 1, right? That's the value that I'm going to get. But when I think about what that looks like in a general term, I'm going to get something that looks like this. A, right? And when I solve all of these, this is in my kind of crunching equations. These equations down here crunch these kind of systematic values into a single number, and these ones move that single number either to the left or to the right on your timeline, or in the past or in the future. So crunching values into a single number, moving them in time. And I can't add things together unless they're in the same time period. So that's kind of what I need to be thinking out in this case. So if I apply this and it solves a VO, the VO is here. Okay, so if I solve this equation and I say that my A equals 1450 and my N equals 60 and my I equals 7%, right? I know how to crunch all these into a single number, all these 1450s. So VO equals 1450 over 1.07 to the 60 minus 1, and that equals, in this case, 2546. Boom. But where is this? So it can be anywhere in here, right? As long as it's on one of these starting points. And if I look at this, the beginning of the first 60-year period would be back over here. Or I could say that it's capturing all of these and bringing them here. in which case I have a 2546 sitting here, but I haven't accounted for that 1450. Okay, so in 10 years, this becomes on a V10, essentially, in this case. So it's a value at year 10. So if I want to do that, I can add the 1450 to it, but I still need to move that back in time. And so if I want to slide it back, all right, I want to take something that's 10 years in the future, which is 1450 and 2546, and I want to go back to year 0. I can do that with a single payment movement, present value, or I'm sliding something to the left using this present value. And so if I take that and I say I want to have VO equals VT, or in this case V10, 1 plus I to the T, and my VT equals 1450 plus 2546, my T equals 10, and my I is still 7%, right? I can plug that in. VO equals 1450 plus 2546, bracket that so it gets done in there correctly, 1.07 to the 10. If I do that, that moves these values over to 0, which is where I'm sitting up here, right? So I've crunched all of these into a single number here, and I move it over that way, and that will give me a VO equals 750.05. And what I didn't do in my little example here was say that I have 100 acres of that. So I have 100 times 750.05, which equals 75.005. That's my answer. So 2 parts, right? I had to crunch things into a single number and do them out that way. Now what's interesting is if you want to play with it a different way and say that I got all of these and slid them back, I would end up in the past. So what that would look like, if there's your 0, right, and I have out 10 or 60, my 1450, and then 70, 60, 1450, and then 1450 out here at 130, 60. So same timeline going on forever and ever and ever. But if I know that these series solve like this, right, where at the beginning of the first n is where the VO is, right, when I solve all of these together, it goes back 60 years from 10, or woo, back here to minus 50. So I'm 50 years back in time here. So with right, Michael J. Fox in my time machine, I can move it forward. So here I'd want to slide that to the right. So I know that when I crunch all of these into a single number, that it is this number right here. So if I take my V minus 50, that's where it's sitting, and it's 25.46. I can also slide that to the right by multiplying it by 1.07 to the 50. And you know what I'll get? My VO in that case is going to be 750.05. Same way. I can do it the same way. As long as I'm consistent, in my approach, I can do that. I can also take this number down here and plug it into that equation right in there. So you can do it many different ways. You just need to account for it. And unlike me, don't forget the 100 acres. This is where we're going to start going with these. It's going to get more complicated. We're going to have more pieces involved. And this is just one example of that. Just you need to stay kind of focused, and you need to keep track of where the values are. You can never add values that aren't in the same year. Once they get into the same year, I can add them together, and then I can move them from there. So that's 25. On to the next one.